Alright, video starting. So this is a review for the first formative for Unit 1, Topic 2. I'm going to try not to talk so fast because I tend to do that a lot. Right? So for your first question here, asked to graph both functions on the coordinate grids provided. Alright, this one's f. Now no, this is a mistake. That should not be f. This one over here should be g. So let's change that to g of x. Alright, so I'll graph the first one first. I think it makes sense to graph both of them before you find all of the characteristics down here. So that's what we're going to do. So calculator, remember, you press the y equals button. This button right here. Right? So f of x is the cube root. Where's the cube root? If I don't know where it is, it's probably in math. So go to math, and you can see that it's the fourth one. So scroll down. You can also press the number 4. Enter. Cube root. Negative x. Remember to use the negative button. Do not use the minus button. Negative x, that's right here, plus 1. Now with my calculator, I have to put the parentheses on. With yours, you may not necessarily need to. So you're going to graph it. All right. So there's that cube root shape right there. So the graph is wonderful. It helps me know what it looks like, but that's not going to help me actually graph it. To graph it successfully, you want to go second, say that second button, and that little arrow means that the second button got hit. Hit graph. All right, here's my lovely points. Now, looking at the span of the graph goes from -10 to +10. So you really don't need to go that far to get there. There we go, -10. So I can see I have some ugly decimals. That's not going to help me. But I see that my first nice point is -7, 2. So let's go -7, 1, 2, 3, 4, 5, 6, 7, and +2. So we're going to put that point right here, -7, 2. You don't have to write the XY table on the side. It does help when you're just organizing things, though. All right, scrolling down. These numbers are not good. Oh, here we go. 0, 1. 0, 1 is a good one. So I'm going to go 0, 1. Right. Continuing downward. Oh, 1, 0, and 2, -1. 1, 0, and 2, -1. So you note that these three, there's like 3 points in a line. So that's always going to happen on a cube root function. Right. Going down, ugly, 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 ugly. Oh, there we go. 9, -2. 9, -2 is a good one. So put 9, -2. Great. So I've graphed this one. A lot of you like to graph the whole thing in one line. Whenever you have something complicated like this, it's best to go in 2 goes. So I start here at my point of symmetry. I'm going to cross through. Make sure you draw your arrows because the graph is going all the way to the right and in this direction. There we go. All right, so there's my first graph. It didn't quite pass through there, but that's fine. All right, and I'm going to graph the second one now. Let's do that one in red. So y equals, clear that. Okay, that function is -square root of x plus 6 minus 3. So you're going to put negative first. That square root button is right where this x squared is. You just need to hit the second button, x squared. There we go. We got x plus 6. Now note the parentheses, not the parentheses, the square root is only on the 6, not on the 3. So with this calculator, I have to put parentheses and then put -3. With the calculators you'll be using, you just need to press the right button a few times to get yourself out of that square root. So graph it. Cool. So it starts one and ends all the way to the error. So hit second table. That'll help me find my points. So you want to generally start from -10 to +10 because those will usually help you. But as you can see right here, I ran into an error. So that error means the graph no longer exists here. So the graph actually starts at -6, -3. So that will be my first point. -6, -3. -6, -3. So first point is right there. Right, go down. -5, -4, -4, -5, -4 is my next one. Right, continuing down on the graph. Nope, nope. Oh, -2, -5 is a nice one. -2, -5, right there. So sorry about the calculator. It keeps disappearing every time I actually tap on the board. No. There we go. 3, -6 is a good one. So 3, -6. I think there's one more. Go all the way down, 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 down. There we go. 10, -7. 10, -7. 1, 2, 3, 4, 5, 6, -7. Now, some people ask the question, well, where do I draw the arrows? So for that, go to graph. So note on the left, this left part, the graph stops existing and it continues beyond, like I guess beyond the screen of the graph. So that's actually where we draw our arrows. So go down this way. With this curve, I probably just draw it in one go, and there's my arrow. So you want to make sure the graphs are drawn correctly, because if your graphs are incorrect, you know your answers are going to be incorrect too. And please try and draw them neatly. It's nice and easy when you're doing classwork, when you have an existing graph, but when you don't have an existing graph, it's not going to look right. So I'm going to do all the characteristics for one of them, and then do all the ones for the other ones. So F, I put F in blue. Let's keep it in blue. So for F, it wants the point of symmetry, or the endpoint. Well, F is a cube root function. Cube root functions have a point of symmetry, which is right there. So that point is called 1, 0. So 1, 0. Please make sure to put parentheses. A lot of you are lazy and don't want to put it on. Make sure those go on there. Now we need to find a domain and a range. So domain is the possible x values. If I go all the way to the left, I see that there's an arrow, and that signifies that there's more all the way to the left of the graph. And also there's a whole bunch of stuff on the right of the graph too. So that domain, there's 3 ways to write this. Choose whichever one you like the best. You can write it as negative infinity, comma infinity. You can write it as negative infinity is less than x, less than infinity. Or all real numbers. Write a fancy R. Don't just draw a regular R, make it fancy. I usually put a line down the middle of it like that. Kind of looks like a P. So yeah, so you pick whichever one you want. You do not have to write all 3. None of you are math teachers. You don't need to know this. Range is actually the same thing as well. If I go all the way down to the bottom of this curve, well, there's an arrow. Even though it doesn't look like it, it is actually going down forever. So for the range here, that is negative infinity all the way to positive infinity. So we're going to write the same things for the range. Except this time, instead of x, it is y. So you got negative infinity to infinity. Negative infinity is less than y is less than infinity, or all real numbers. R. There we go. That's a lot nicer. All right. Now we got our next questions of increasing and decreasing interval. Well, remember, we read graphs from left to right. Let me move the recording out of the way. So from left to right, we are actually going down. So if we're going left as we go, if we're going down as we're going from left to right, that is decreasing. So we're not increasing. So on the increasing graph, just write NA for not applicable. You can write none. You can write no. A few of you wrote not. Please don't write not. Not is not an answer. So decreasing interval. For the decreasing interval, well, it is decreasing. Let me move that back up again. From negative infinity to infinity. So with this, you can honestly just copy the domain. So just write the same thing you wrote in your domain. I'm going to be really lazy and just write R for all real numbers. That's an acceptable answer. All right. Also, one thing to note, remember, domain is x, range is y. Decreasing intervals are the same as that domain, so you need to use x if you're going to use this notation with the inequality symbols. Right? So that is F. Let's go to G. So G is a lovely square root graph. It's kind of upside down. Well, this one, I don't want the point of symmetry. I want the endpoint. So the endpoint is right there. So that is -6, comma, -3. So -6, comma, -3. That's a really easy question. Right. For F, basically everything is R. Domain R, all real numbers. Cube roots are easy. With square roots, you got to think a little more. So remember, domain is the all possible x values. So if I go to the left, that's from -6 and it kind of keeps going on to the right of the graph. So the graph starts to exist at -6, continues all the way to the right. So my domain, there are two ways to write this. You can write it as -6 comma infinity, or you can write it as x is greater than or equal to -6. Now, when you are using, if you decide to use this notation up here, you need to put the square brackets for the numbers, and you need to use parentheses for the infinities. Please don't leave it blank. Like this is math grammar. You can't not follow math grammar. Right? Range. The range is a little bit difficult here because we're decreasing. Well, think. If I go, when does the graph start to exist on the y-axis? It starts to exist at right here, and that number is -3. But there's still more underneath. In fact, there's more all the way to -infinity. So the way you would write the range here is from -infinity, comma, -3, right? Or y is less or equal to -3. Make sure to use y for the range, please. Like the first graph, this graph is not increasing, this is decreasing. As I go from left to right, pencil's going down. So again, not applicable. I'm telling you right now, on your quiz, like one of these is going to be NA, always. And the other one's the answer. Decreasing interval, well, it's decreasing all the time. So again, we can just copy the domain. -6, comma, infinity. X is greater than or equal to -6. Please pick one of these. You do not need to pick, you don't need to know all three. So here are the key characteristics. That's done. Number 3, this is average rate of change. Now, we learned this recently, so it's a little bit fresh in our minds. I'm going to write the average rate of change formula kind of small over here. So remember, average rate of change is, I got to find a good space for it. Let's just do it right here. That is f of b minus f of a divided by b minus a. This is just a really, really fancy way of writing the slope formula. All right. So first things first, this is graph 1. I need to find the average rate of change of here between 0 and 3. So remember, the first number in our interval is a. Second number in the interval is b. So before you do anything, let's just set up this function right here. So that's going to be f of b, which is 3, minus f of a. Well, a is 0. Divided by b minus a. Well, b is 3, a is 0, so b minus a, 3 minus 0. Cool, you set it up. Awesome. The hard part is actually finding the f of 3 and finding the f of 0. So there's two ways to do it. I'm going to show you the long way and then the short way. Either way is honestly correct, but I guess the long way has a little more integrity. So the long way is to plug the answer in, or just plug in the number. So f of 3 equals, and in this case we need to use the original function. So the original function is up here, cube root of negative x plus 1. So I don't think I have enough space. There you go. So that's the cube root of negative x. Let me fix that. Instead of negative x, it's going to be negative 3. Negative 3 plus 1. All right, so I did that. So let's keep following the equation. Cube root. Well, negative 3 plus 1 is negative 2. So that's that cube root of negative 2. And what we can do now is, most of you don't know how to do this by hand. Neither do I. So that's where you're going to go into your main menu. By the way, if you want to go back to your main menu on the calculator, hit second, and you see quit. That'll get back to your home screen. So go the cube root of negative 2. And that is a wonderfully terrible number. Yeah, negative 1.259. Let's round that to negative 1.260. That's about, and I'm putting a squiggly equal sign. That means approximately. It's about 1.260, right? So there's f of 3. I'm going to use this one as a replacement for what I put here. So that's going to be negative 1.260. So I found f of 3. Now I need to find f of 0. So f of 0, I'm going to do it right here. We're going to have to do the cube root again. This time it's cube root of, instead of 3, look back at the equation, negative x. So instead of negative x, I put negative 0 plus 1. Okay, so, well, we can do the inside part. Remember, negative 0 is just 0. So 0 plus 1 is 1. And what's the cube root of 1? That's just, oops. Cube root of 1 is just 1. So I'm not even going to waste, I'm not going to waste vertical space. That's just 1. So my answer for f of 0 is 1. So instead of f of 3 minus f of 0, that's negative 1.260 minus 1. All right, let's divide that. Well, 3 minus 0 is just 3. And now what do I got? Negative 1.260 minus 1. I already have the answer. You can just put it in your calculator if you want. But that is equals negative 2.26 divided by 3. I'm okay with you leaving it like that. If you really want to be annoying and put it in the calculator again, you're going to get about 0.753. And then box your answer just to make it easy for me or whatever teacher's grading your test. So there's my average rate of change for the first one. Now, that does take kind of a while, especially because I'm talking over it. So I'm going to show you a really annoying trick. Well, instead of doing all the work, the calculator can do it all for you. It always does it for you. You just don't know about it. So erase that. Go to y equals. This was the second equation. I don't need that. Let's write the first equation again. That's cube root of negative x plus 1. Good. Now, you go to second table. Now, it was asking for f of 3. Well, let's scroll to f of 3. Oh, isn't that negative 1.26? That is the same answer I got here. So you can save a lot of time by just using second table. And it even works for 0. I'm going to scroll up to 0. Oh, hey, look, 0 got me 1. Hey, look, I got 1. So it saves a lot of time. Just second table it if you really just want to get a quick answer. So yeah, second table is completely a viable option. So let's do the same thing for the second one. Remember, negative 5 is your A, negative 3 is your B. So we're going to follow that formula. That is f of negative 3 minus f of negative 5 divided by negative 3 minus negative 5. A lot of people are going to forget that minus minus. Negative, negative, negative. It's negative 3 minus negative 5. All right? We can do this all off to the side too. So I need to find f of negative 3. So f of negative 3 is some ugly number. F of negative 3, scroll up. That is, wait, why am I saying f? Oh, there's a mistake there. So they're asking for the average rate of change here. Instead of f, I say we should put g. That's a little more appropriate. I apologize to those who are following along. Yeah, g is more appropriate. I mean, it doesn't matter too much, but yeah. So g of negative 3, in fact. So what is g? That's negative square root of x plus 6 minus 3. So instead of writing x, you're going to write whatever the value is, where that's negative 3. So that's, let me move this over again. That is negative square root, and instead of x, you put negative 3 plus 6, and the minus 3 on the end is outside of that square root. Sorry, so let's do this all together here. Keep that negative, because it's still on the outside. Negative 3 plus 6 is positive 3 minus 3. All right, so this is all really, really ugly. Don't do it in pieces. Just do it all at once. You can totally use the calculator for this. So, right here. So you want negative square root of 3. So second quit out of there. Negative square root of 3. The square root is right here. 3 minus 3. Boom. So that's negative 4.732. Yeah. So you got negative 3, negative square root of 3 minus 3. That is negative 4 point, what is that? Negative 4.732. Oops. Negative 4.732. Just double checking because it seems my answer doesn't quite match up with it. Well, I'm just going to use the cheaty way and just check if my answer's not right. So, yeah, I'm using a paper, and I seem to have written it wrong on the paper, so I'm just going to test it using second table, because calculators are amazing. X plus 6 minus 3. Second table, was I right or was I wrong? Is that negative 3? Yep, I was wrong the first time, so I have to erase this and then fix it on my own paper. So this one's right. And then now let's find g of 5. Negative 5, sorry. G of negative 5, so instead of negative x, I put square root. Wait, instead of not negative. Instead of x, I put a negative 5 plus 6 minus 3. I'm running out of room a little bit. So negative 5 plus 6 is easy. That's just a positive 1. So negative square root of 1 minus 3. Well, the square root of 1 is just 1. And so it's really negative 1 minus 3. That is negative 4. So let's put all these numbers in here. All right, I've definitely run out of room here, so I'm going to write it underneath. So that is negative 4.732. 3 decimal places is really good, because that's exactly what you have on the AP exam, if you want to take that class. Minus negative 4 divided by, and then whatever, okay, negative 3 minus minus 5. Remember, minus and minus makes a plus. So that's negative 3 plus 5. That is 2. Right? And then since the answer was wrong on my paper, I actually have to do it on the board. Put out of there. That is negative 4.732. Remember, minus and a minus is a plus, so just put a plus. Don't do double minuses. I don't think that really works well on calculators. 4. So that's negative 0.732 over 2. So negative forgot what it was already. 732 divided by 2. I would leave it here. You don't need to really go nuts, but if you really want to do that, you would just divide it. On cool trick, if you just press divide, it'll just take whatever number you did here. You don't even have to type it in again. So negative 0.336. Negative 0.336. And then box your answer to be nice. I hope I did not make a mistake. So here's your first page. So again, if you want to avoid doing all this heavy calculator work, you can always go to second table, provided that you have the right equation in the graph, second table, and then just check. So g of negative 3 is negative 4.732, and g of negative 5, whoops, yeah, is negative 4. Yeah, that works. I am second guessing myself. Right, so that is the first page. Boom. All right, and then we got a back page, moving to the right. Okay, so this one's matching the graph with the graph of its inverse. This one's really nice, just because it's matching. Matching is really wonderful. So let's just start with the first one. So it's going up here. Remember, when you're graphing an inverse, it is a reflection over the line y equals x. So you need to imagine there is a little y equals x line there. And imagine you're flipping it over. If I flipped it over this line, it would end up looking kind of like that, right? And the only one that matches that is A. So that one would just be A. I'm okay with you drawing arrows. They're kind of annoying. I know other teachers don't like you drawing arrows, so some people will just ask you, just put the letter A to make it really obvious. Just say it's A here. All right? Let's take a look at the second one. Again, it needs to look like a reflection over the line y equals x. It needs to look like a reflection over that line. Which one looks like a reflection? Well, this point would reflect over here, and then it's going to kind of look like that. Which one is that? So that's clearly C. Oh, just write C there. Or if you want to just draw an arrow, cool. I'm all right with that. All right, and by process of elimination, B is this third one, so just write B. Draw a little the little arrows to stress out whichever teacher you have. All right. Matching is pretty easy. Hopefully no one's going to mess up on this one. All right. We got one last question. So this is the restriction question. Now, a lot of people don't quite get this. Again, with domain restrictions, like it is kind of conceptually difficult. So we are going to graph this. Well, what we want to do first is we want to identify a restriction on the domain of the original function to make sure that the inverse is a function. Now, if I just draw the inverse any way I want, it's going to look something like this. I'm just going to draw it like really quickly. Like it's going to look like that. The problem is this inverse is not a function because it fails that vertical line test. See, if I draw a vertical line through here, it passes through 2 points. And then that's not okay. That's not a function. But it would be okay if I only had one part. Right? If this part was here, or if this part was here. If you had just one of those, it would still be a function. So what we want to do is we actually want to cut this original graph into just a part that'll create like an upper curve or a lower curve on the other one. Most people will probably just pick the right side. So highlighter, here we go. So I'm just going to pick the right side because it's nice and lovely. I'll also show you the left side as well. So if I'm only picking the right side of the graph, well, the right side of the graph in terms of domain, so, and when they say restriction of the domain, remember the domain restriction is x. So we want x to be, well, x's are all positive here, so we want x to be greater than 0. So that's a possible restriction on the domain. Well, if x is greater than 0, that means I only want these points. And what I'm going to do is I'm going to flip them around. So what's this point? This point is 1, 4. I think this is 2, 1, 2, 3, 4, 5, 6, 7. 2, 7. Right? 1, 4, 2, 7. I think I'm missing one. Oh, I can also use this one too. I mean, it says like greater than 0, but we can still use it just to help us draw. Actually, it's probably more appropriate to put it there. There we go. That is 0, 3. Cool. So remember, when we were just graphing the inverse, all you do is just switch your x's and y's. So instead of 0, 3, it is now 3, 0. Instead of 1, 4, it is 4, 1. Instead of 2, 7, it is 7, 2. And there we go. So now you can totally do it like that. We also did forget to write out the inverse. So remember, when you're writing the inverse, and I know a lot of you think this is annoying and like, why am I wasting my time? But a lot of you still mess this up. So you focus on the x first. What's happening to the x? First thing that happens to the x is it is being squared. After I square it, I will add 3. So when we're trying to find the inverse, remember, you invert the steps completely. You're doing everything in reverse. Like you're eating a cookie. The opposite of eating the cookie is throwing it back up. So what's the last thing I did? The last thing I did was add 3. So what's the opposite of adding 3? The opposite of adding 3 is subtracting 3. What's the opposite of squaring? That is a square root. So we're going to use these steps to help us create that inverse function. So always start with x. Always just start with an x. What do I do with the x? Subtract 3. Then I take a square root of the whole thing, not just the x. You need to follow these steps in order. If you take the square root of just the x and you just didn't follow the steps, that's you doing the square root first and then subtracting 3. But yeah, so you can totally do this. And like, yeah, this is a completely reasonable response, full points. Yay. So you can stop the video here if you want. If you want to be an overachiever though and then show some other versions, you show the other version. So some of you are kind of crazy and saying, I don't feel like using the positive side. I want to use the negative side. If I want to use the negative side, I'm going to change all these. And that's going to be less than or equal to 0. And if I want that negative side of the graph, that's going to be highlighter that way. Like that. Well, on the negative side of the graph, we're going to do the same thing. So we're going to use this point. That is 0, 3. This point is negative 1, 4. That one here is negative 2, 1, 2, 3, 4, 5, 6, 7. Negative 2, 7. Yeah, I don't know why this is hard. It's just the same numbers, just they're not negative. So let's put these numbers as the inverses. That's going to be, instead of 0, 3, that's going to be 3, 0 again. Instead of negative 1, 4, that's going to be 4, negative 1. Instead of negative 2, 7, that's 7, negative 2. Well, it's not curving up, it's curving down. So we actually need to change the function to, oops, change the function to make this work. There we go. It's not square root of x minus 3. This is actually negative square root of x minus 3. So if you want to be crazy and go this route and then just show everybody that, man, I know inverses really well, cool, you can totally do this. So this is a totally acceptable answer. But most people would probably just make it positive. I'll just go back in time. And yeah, most people would just use the positive side. I like using the undo button. Yeah. So most people would just choose the positive side and just graph it like that. There you go, full points. Cool. All right, so there's everything, and I'm done. Bye-bye.